This is the Introduction to Python workshop. My name is Jonathan DeConing. Let's get right into it. Okay. This is the check-in QR code. If you are a member of ACM or want to be a member, if you check in, you'll get some event points. Get enough of those and you'll be invited to the banquet and get a stole upon graduation. So check in for sure. All right. What can you expect from this? What's kind of the outline of this workshop? First, we'll go over pretty briefly what Python is, then why you should use it, why it's a good tool to learn, how to use it, so we'll go over some syntax stuff, variables, loops, conditionals. We'll work on coding up some projects and examples. And then after we get into how to use Python, we will look at how to use Python, meaning the very Pythonic sort of idiomatic Python things you can do with like list comprehensions and real neat sort of syntactical sugar and some really great features of Python the language rather than Python as a programming language. It's Python specifics. And then if we have time after that, then we'll do a bit more practice. Okay. So what is Python? As I'm sure many or all of you are aware, Python is a programming language. And it's an interpreted programming language, so not compiled. Interpreted means that there's a Python interpreter which will run through the code line by line and execute it, as opposed to compiled, which will take a look at all your code and then optimize it and convert it to machine code to make it really fast. So it's interpreted, which means it is not as fast as most compiled languages, but it often makes up for it in some real nice syntax trade-offs, and you'll see the code density is really nice as well. It's multi-paradigm, so it's not a strictly object-oriented programming language. It's not a strictly functional programming language. It kind of has the best of both worlds. You can do functional stuff, you can do object-oriented stuff, you can just do regular sort of declarative programming. You kind of get a whole mixed bag, and it's really nice. And it's used mostly in small scripts, data science, right, to visualize some data. AI, machine learning is kind of the core reasons you would use Python. Speaking of why you should use Python, again, the simple syntax, great for interviews. One, there's so much less stuff you have to remember. It's very, Python is almost like pseudocode. You just kind of write what you want to see, and it happens, and it's really excellent. The syntactic sugar, and there's an extensive library for doing all sorts of stuff that you could ever need, and allows you to code just really fast. If you think of something you want to make, there's usually a way to do it really efficiently, really fast, with little code, and it's super helpful to just know what you want to do and then make it. It's a common language in industry. Maybe not as common as some languages like JavaScript or depending on your field, you could be using a lot of C++ or things like this. But it is a very common language, and learning Python is helpful. It's great for that. It's a super easy language to pick up, again, because of its simple syntax. And it's a good introduction to different paradigms. If you want to try out some functional programming, Python has tools for that. If you want to learn some object-oriented stuff, it's also got tools for that. And then you can branch out to some other more focused languages after that. Okay, so let's give an example of what Python code can really do for you. This here is an example of some Java code. And what this Java code does is it takes some array of numbers, and what it's going to do is print out the sorted unique numbers, right? So we're going to get we've got 5, 3, 9, 1, 5, and 3. And so we want only the unique numbers, and we want them sorted, which would be what? It'd be 1, 3, 5, 9, right? So the way you could do this in Java is you have your import statement, which will import kind of all the stuff you need. You've got your main class with your main function. We've got a list of integers called numbers, which is an array. We turn that into there. And then we process it, save that into a variable called result, and then print out the result. And how do we process it? Well, we get all the unique numbers by converting it into a hash set, which only has unique numbers. And then our sorted list is a new array list with those unique numbers. And then we call collections.sort on it, return sorted, and then we're done. Okay, so how can we convert this to Python? Well, first of all, Python doesn't need a main class. The main class kind of just is the Python file, so you can just write it starting from line 1. You can write like print hello world, run it, and it'll just execute. You don't need any sort of main class to run your Python code. So we can get rid of that. What else can we get rid of? Well, the main function. Again, in Python, kind of just like your beginning file is the main class and the main function. If you're coming from Java, you can just start writing from line 1. What else can we get rid of? Okay, we can get rid of this import statement. We're not going to need that, of course, because we're using Python, not Java. And then what I'm going to do is move the process function up to the top and this kind of main driver code to the bottom, like so. Okay, what else can we do? We can remove these data structure types, right? So Python is dynamically typed, meaning that you don't need to declare what type of variable is. So an example for like Java, if you want an integer, you would say int my integer equals 4. In Python, you would just say like my integer equals 4, no semicolon. It's interpreted just automatically, and you can do some typecasting if you want to change the variables, but we don't need this, so we can remove that. What else can we remove? We can remove the semicolons. Python doesn't use semicolons, so that's nice. What else? This is how we declare a function in Python. We have def, which stands for define, and then we don't need the static keyword. We just say process, nums, and then instead of a curly brace, we use a colon and indentation, right? So there's no curly braces in Python to separate out your code. The code blocks are defined by indentation. So all the lines that are indented under the function header is going to be part of that function. And then once it's unindented, then you're back in the main function. Okay, what else? We can remove this hash set and array list, and just, this is how we define a hash set in Python. We say set nums. We don't need to declare a type or anything. And then the sorted function will take that and create a list of those unique numbers. So we just say unique is equal to set nums, and we return that sorted set. And then here we can, instead of defining arrays.asList to get our array, we can, the way you kind of show that in Python is just with some brackets, and then we can convert system.out.println, which is kind of ugly and long, to just print, and this is very kind of simple. Okay. So we went from this to essentially this. I did a bit more, right? So now we have some stuff that's kind of nested. So our process function is now just one line. We return the sorted set of numbers. And then for our driver code, we have numbers, and then we print the processed numbers. And if we wanted to do this all in one line, we have print. And what are we printing? We're printing some sorted set, and the set again removes all the duplicate values of this array. So that's a big code change, right? So again, Python really lets you just like get at the heart of the problem, and kind of you don't have to deal with all this extra sort of requirements, which does make it slower, right? This Java code is going to be faster, but or I mean, well, maybe not for this small list, but if you have a larger list, then the Java is going to be faster. Okay. So how do we use Python? How do we start using this language, which seems like magic? We have to start with basic syntax, our variables and types, indentation-based blocks, we went over that a bit, some basic input and output, look at some of the ways you do the math, and take a look at comments. So let's start with variables and types. If you want to follow along, I would Google Jupyter Notebook. And if you go to Jupyter Notebook, this try tab or header, you want to go to try, and then Jupyter Lite. It loads, and then I think this is just some leftover stuff. But you create a new notebook here. That's a bit more than I was wanting. Jupyter Lab then might be better. But Jupyter Notebooks are really nice, especially for data science. It allows you to define like modular sections of your code and run specific ones instead of all at once. So you could open up this Jupyter Lab thing here, delete all this, and open up a new notebook like so. And I'll give you all a few seconds to get that up and running. Yes. Close the screen share. I mean, the tab's still open. All right. So Python, how do we define a variable? Well, it's pretty simple. You say the name of the variable, you put an equal sign, and then you put your data, maybe 7, right? No semicolons, no nothing. Once this line executes, you now have a variable named variable, which is equal to 7. 7 is going to be interpreted as an integer. If you want it to be interpreted as a float, you can add a decimal, 7.0. This is now a float. If you want it to be a string, you just put a string in there, right? You don't have to specify the type. You don't have to say string variable, none of this sort of stuff. It's just very kind of linear, right? So then if you have multiple variables, like A is equal to 5, B is equal to 4, and say you want to know what these two variables added together are. So you could have some new variable, total, is equal to A plus B, and say we want to see what the total is. The way you do output in Python is a print statement, which can print strings, it can print variables, it can print all sorts of stuff. And then if we execute this block, we're going to get 9, right? Super simple. A equals 5, B equals 4, total is equal to A plus B, and then we print the total. If we wanted to have these variables be dynamic, what we would do is use the input function. So input and print are kind of the very basic input and output functions in Python. So we could say A is equal to input, B is equal to input, and input will read one line. And then we can print A plus B. And something interesting will happen, but you'll see. Okay, for our first number, we'll do 5. Perfect. For our second number, we'll put in 4. And it prints out 54. And the reason it prints out 54 and not 9 is because by default, input reads in strings, right? You're typing in strings, and so it's thinking, oh, this is the text, you know, the text character 5 and the text character 4. So if we want to interpret these as integers, we can say something like this. We could do int a plus int b, and this will convert them to integers, or just temporarily, right? So if we still work with them afterwards, they're still going to be defined as strings. This is just temporarily, we get a new value with the integer of a and the integer interpretation of b, and then we print that. Alternatively, if we wanted to just convert it and never have to do anything else with it, we can just say a is equal to int a, and this will convert it permanently. B is equal to integer b, and then we can print a plus b. And this will give us 5 plus 4 is 9. And if you wanted to do this all in one line for each, you can say a is equal to integer input. Whoops. Right? Just like that. And this is how you convert things to different types. So if you wanted to convert an integer to a string, you would say something like x is equal to stir x. Convert integers to floats, floats to integers, all that kind of stuff. It's super simple with just one method or a function. Your int, your stir, float, any sort of thing. Okay. So that's input, that's output. What else do we have? Indentation-based blocks, you saw some of that. We can go over some more math stuff. So you have, let's say a is equal to 5 again, b is equal to 4. Doing math in Python is pretty simple. We can say a plus b, we've seen, that's going to give us 9. Or it might be better if I do print a plus b is 9, a minus b, 1, a times b, 20. The main difference in math with Python when you compare it with other languages is a lot of languages, your division operator here, this will be integer division, right? So for example, if we had 21 divided by 4, this would be integer division, meaning that it would just divide as many times as it can and get rid of the remainder, which would be, 5? But in Python, the single / is float division. So this is going to give you the actual value. If you want integer division, you do 2 division signs, and that will give you 5. There's also a math module in Python. You can say import math. And this comes with a whole bunch of cool functions, like the ceiling function, the floor function. You can do square root stuff. I mean, if you're interested, you can just go like this, Python math module, go to the documentation, and see all of the different functions that they allow you to use. Stuff with logs, using E. This gives you Euclidean distance between 2 points, all sorts of stuff, all you could ever need. So maybe we don't want to do integer division, and we would rather just round up everything, in which case we could say ceil, which is ceiling, which will just take some decimal number and round up always. And this should be, I need to say math.ceil. And this will give us 6, right? 21 divided by 4 is 5.25. And then if we run the ceiling function on that, that'll give us 6. Another way to import things in Python is we can say, instead of import math, we'll say from math, import ceil. And so this will just import that one function. And then we don't need to call math.ceil, we can just call ceil. Okay. Comments in Python. are pretty simple, but a bit different than Java and C. So in Java and C, you'll have this double slash and then your text. But the double slash, again, is for integer division in Python. So the way you do comments in Python is with a single hashtag. This is a comment. Something like this. Right? If you want to do multi-line comments, the way you do that is pretty interesting, actually. There's no inbuilt way to do multi-line comments. So the standard way in Python for multi-line comments is actually to define a multi-line string. And what this is going to do is nothing, because it's a comment. But what's actually happening is when the Python interpreter runs through this code, it's executing this, but this doesn't do anything for the program. It just executes the string, which doesn't really do anything. And it doesn't raise an error. You just have a string that's being defined but not saved. And you can use that as a comment, which is kind of a weird sort of, I'm not sure why there's no inbuilt functionality for a multi-line comment, but this has been adopted. So you'll do this triple quotes. This can also be triple single quotes, but the standard is to use triple double quotes. All right. But what is a programming language without... Oh, my apologies. We'll do an exercise first. A temperature converter. Okay. Let's say we want to convert Fahrenheit to Celsius using what we've learned about Python. Okay. How should we go about this? Well, let's first get the temperature from the user. And we learned how to do that with our input function. Say temp is equal to input. But again, this is what? This is being read in as a string. So we need to convert this to probably a float. Floating point number would be better than an integer, typically for temperatures, right? And then, does anyone know the formula off the top of their head? No? Let's find out. Okay. The temperature in Fahrenheit minus 32 times 5 divided by 9. So Celsius is going to be equal to the temperature minus 32 multiplied by 5 divided by 9. And parentheses will denote order of operation if you don't want it to be the default order, right? Just like in Java or C. And then we can print Celsius. Okay. So let's do it. Let's see. 212 is the boiling point of water in Fahrenheit, which should be 100 in Celsius. And there you have it. Right? So this is simple, sort of, no kind of complicated control flow or conditionals, just a really basic input, math, output example to put together kind of everything we've learned. And we can add some comments if we want as well. Just like that. So that example should put together variables, types, we're doing some converting, no indentation in this example, but we have IO, we have math, we've got comments, and we have a temperature converter. Okay. On to control flow. This is where programming really starts, right? You have your conditionals, if, elif, else. You have loops. You have a secret technique that I'm going to show you, which is one of my favorite sort of Python capabilities. But let's start with just conditionals, if, elif, and else. So in, I think C and Java, they're elif. If you have like a conditional, right? Like if x is equal to do something, and then they have else if x is equal to 3. In Python, this else if is elif. So it's just kind of shortened, which is pretty standard for Python, shortening things. But we use elif. So if elif x is equal to 3, do something else, and then else do the other thing. So since it's nearing the end of the spring semester, I'm assuming most, if not all of you, have some programming experience in Java or C or whatever you've been learning. So you're familiar with conditionals, so I'm not going to go into why they're useful, but we will kind of look at some examples. So if we have some number, which will be given as an input, and we will convert that to an integer, we could do a conditional like this. If number modulo 2 is equal to 0, and this is just checking for evenness or oddness, depending on how you write it out. So in this case, if the number when divided by 2 has a remainder of 0, then that means it's even, so we will print even. Else we can print odd, right? And then if we run this and we put in a number 5, it says odd, right? Just what we expect. Again, Python blocks, no braces, just indentation, and you denote the start of a new block with this colon. Excuse me. Or maybe not. Okay. All right. And if we want to put in an elif or an else, we could do something like this. If number is greater than 100, print big. Elif number is greater than 50, print medium. Else print small. Then if we put in a number like 75, that's a medium number. If we put in a number like 2000, that's a big number. And if we put in a number like 3, that's small. And that's about as complicated as conditionals get. I mean, unless the thing that you're checking is complicated. But it's just if, elif, and else. So that's kind of how you convert, that's how you do that in Python. When we get into loops, though, for loops, while loops, that is a bit more complicated. So your typical for loop in C or Java would look something like for int I equals 0, right? I less than 10, I plus plus, and then you have these braces. The way you do this in Python is you say for I in range 10. And then we can print I, and I'll explain what's happening. Actually, let's do I in range num. That'll be nice. So if we put in a number like 8, that's going to go 0, 1, 2, 3, 4, 5, 6, 7. So this is end exclusive, right? So it starts at 0 and will go all the way up to, but not including your number. And it'll print out 8 numbers, right? Of course. So what's happening here under the hood, which isn't terribly important to know right now, but it's still nice. This range function creates a range object, which has a start, a stop, and sometimes a step. And by default, if you only provide one parameter to this range function, it's going to have an initial start value of 0. So what this converts to is like some range object where the start is equal to 0 and the stop is equal to num, or 8 in this case. And then this for loop is just kind of going through it, iterating. Actually, yeah, this might be, we don't need to get into the weeds for that. But if you have this syntax, so you have your variable, I in this case, and we say for I in range number, we can define our own sort of starting and stopping point. So instead of just num, we can declare 3 to 10, and that'll print 3, 4, 5, 6, 7, 8, 9. Remember, the end is exclusive. And if we want, we can also specify a step. So something like this is going to go from 3 up to, but not including 10, and every 2 steps, right? So 3 plus 2 is 5, plus 7, plus 2 is 7, plus 2 is 9, and we can print I. So if we were to use this to index some sort of list of names, and we haven't gone into lists just yet, but we will. Say Bob, Jane, Emil, and Larry. We can say for I in range, and we get the length of this array. For I in range length of names, we can print names at this index. And there we have Bob, Jane, Emil, and Larry. Right? So what's happening is instead of putting nums into this range object, the amount of times we want to iterate from 0 up to that number is the length of the array that we're looking at. And then for each of those iterations, we just index our names array. So this is going to go from 0, 1, 2, and 3, and then we print out names at location 1, names at location 0, names at location 1, names at location 2, names at location 3. So this is how you would do it generally in C, right? You have that I counter index variable. Instead, what's nice is we can do this for name and names. And we print name. And this does the same thing. So now instead of iterating over the indices, we can iterate over the actual values themselves. And this looks really pretty, right? You just say for name and names, print your name, and you're done. Obviously, there are situations where you want the indices, so you can do things with the indices. Sometimes you want the name or just the value itself. Sometimes you want both, right? And so you could say for I in range length of names, and then say name is equal to names at I, right? So now we have the I variable, which is the index, and the name variable, which is the value, and then we can print I and name, and that'll give us this. And if you give multiple values to your print function, it'll just separate it out with a space. That's what that does. So now we can print the I, we can get the name, and we have that all in one loop. It's very nice. Bob is at position 0, Jane is at index 1, Emil is at location 2, so on and so forth. A secret technique, you can do this. And just kind of get it over with. Oops. So enumerate is a function in Python that does exactly what we just did. It's going to let you iterate through and get the index and the value at the same time, so you don't have to have that those extra lines of code. But that's just like a kind of side thing that I think is cool. Okay. A while loop in Python is very similar to the for loop that we've seen. You have your while, you have your condition. Let's say, while x is greater than 0, and then the body of your loop is going to execute whenever x is greater than 0, and if it ever becomes less than or equal to 0, then it will break out of that loop and continue execution from there. So we can say, well, x is greater than 0. If, say, x is divisible by 10, we can print x. If x is divisible by 10, then we print x, and regardless of whether or not it's divisible by 10, we subtract 1 from x for each loop. And so this will go from 100 to 99 to 98, and eventually it will hit 0, and this condition will fail, it will exit the loop, and we print kaboom, right? So now we've implemented a nice little countdown, 100, 90, 80, 70, until we exit that while loop, and we're finished. So this is some nested blocks, of course. One of the issues that a lot of people have with Python is the forced indentation. They would prefer to have curly braces where they can kind of move and modify it how they like. And that might be you. I personally prefer the indentation, which might sound a little crazy. I like the forced sort of structure. That's just a side note. So you've got your loop, you've got a conditional, you've got input, you've got math, and you've got a comment. Let's do input. Input. And so this example here really shows everything that we've learned so far. What we could do is maybe do an else, right? If it's not divisible by 10, then, or how about this? Elif x is divisible by 5, print maybe some spaces, something like this. Looks kind of funny. Ignore that. It's mostly for me. Okay. All right. So continue and break. If we want to exit a loop early or stop the current loop and go to the next iteration of a loop, we use the continue and break keywords. So we can do something like this. Say nums is equal to, say, 3, 5, 7, 9, 10, 13, 15, 12. And let's do, actually let's do this. We've got some string, and we will have some index variable, which will start at 0. And what we're going to do is we're going to go through this string, and once we see some character that we're looking for, we will stop the loop, and that will let us see where that character is. So if we're searching for, say, the character W, right? So we have this string, we have what we're looking for. We can say for I in range, length of S, character is equal to S at that location I. And if that character is equal to our search, what we're looking for, then we will say found character at position I. So in this case, we're searching for W, and we found it at position 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There it is. But if we do something like this, we change this to short young woman, then we're going to find the character at position 9 and the one at position 23, which might be fine if we're trying to find all the characters at all the positions. But if we just want the first one, then we will print found character position I, and then we will break, which will stop the loop and exit out. So then if we run this, we just get the character position 9. Okay. Let's build FizzBuzz. Who here is familiar with FizzBuzz? Has heard of FizzBuzz before? Jacob? You don't know what FizzBuzz is? Miguel? You know what FizzBuzz is? You know what FizzBuzz is? Okay, like raise your hand or something. FizzBuzz. Okay, FizzBuzz is a pretty standard sort of interview question that you'll hear about. And the way it works is this. We've got some number. We're going to iterate through all the numbers from 0 up to that ending number. And if the number is divisible by 3, we print fizz. If it's divisible by 5, we print fizz. We print buzz. And if it's divisible by both 3 and 5, we print FizzBuzz. Otherwise, we just print the number. So let's do that. We'll say our number is equal to some integer input. And what we can do is go for I in range num. And what? If I is divisible by 3 and I is divisible by 5. So compared to C in Java, if you're doing an AND, you'll actually just type out AND instead of the double ampersands. Same for OR. Instead of the double pipes, you just type OR. So if it's divisible by 3 and divisible by 5, then we will print FizzBuzz. do if I is divisible by 3 print fizz, then we run into a problem, right? Because if we hit 15, then this is going to execute because it is divisible by 3 and it is divisible by 5. Sorry, this should be like this. So we'll print fizzbuzz, but then we'll get to this line and we'll also print out fizz, which isn't what we want. We want just the top level sort of condition to execute. So what we can do is print fizzbuzz and then continue, which is kind of break's cousin, but instead of breaking out of the entire loop, we will instead just break out of the current iteration of the loop and jump back to the top and start all over. So then we can do this, print fizz, continue, and if I is divisible by 5, we print buzz and continue. Now, of course, we don't necessarily have to do the continues. We could do like an if and elif sort of thing. But I want you to know about continue if you didn't already. But if we get to this part of the code, that means that none of these triggered, right? Because if they had triggered, then they would have continued. And so if we're here, then it's not divisible by 3 and it's not divisible by 5. So we can print just the number. And if we run this and give it 25, oh, whoops, print I. Okay. 25, then we get 1, 2, fizz, 4, 5 is buzz, 6 is fizz, 7, 8, right, until we get to 15, that's fizz buzz, so on and so forth. Perfect. I should probably have been pausing for questions. Does anybody have any questions up until this point? No? Okay. All right. The secret technique that I told you I would teach you. This is pretty interesting. In Python, you can have a for else loop. So something like for, and then you have your body, and then else. And the way this works is if you have like something like this. If you say for name in names, right, iterating through all the names. If the length of the name is less than or equal to 3, then we break. Right? This else block, if you have a for else loop, the else block is only going to trigger if you went through the entire loop without breaking. So this else block here, we can say no short names. And in here we can say short name found. So in this case, we're going through all the names. We find Bob, which is a short name. So we print short name found and then break. But if we did something like this, now there are no short names because this else block triggers because we never broke out of the loop. So that's kind of interesting. That's a kind of neat way to clean up some of your code instead of if you were to do this in like C or Java, you might have some like flag like found short is equal to false, and then you do found short is equal to true if this happens. And then after all of this is true, you say if not found short, print no short names, right? But the for else loop is pretty Pythonic and idiomatic. All right. Oops. Data structures. We've seen some of these already. Starting with strings, if we have a string, name is equal to Jonathan. I think of strings as data structures. I mean, in C, they are arrays of characters. But strings in Python have a lot of methods you can use to modify them. So, for example, we can say print name.upper, and that'll give you the uppercase. You can say name.lower. It'll give you Jonathan in all lowercase. And if you want, you can see all of these. Oh, that's not the string methods. Let's do. You got capitalize, case fold, whatever that is. You can center strings, count stuff, encode, see if something ends with something, find, format, all of these sorts of things. You've got name.isDigit. This is true because this is a string, but it's a string that represents a digit. If this is like P, then that's going to be false. There's so many different like methods that you can use in Python to just get your coding done really fast and what you're looking for, right? Because this is digit sort of thing. This doesn't exist naturally in C, right? You'd have to code all that, which is annoying. In Python, it just exists. If you're looking to get into doing some serious Python stuff, I would heavily recommend checking out like all the stuff that's available to you. The itertools module, collections, all the functions for lists and strings, and there's so much, so many options available in Python that, I mean, are wonderful. You just again think what you want to do, and you can do it, and it's super helpful. But onto the big boy data structures, you've got your lists. If we say, let's do nums. So right now, nums is an empty list, which is just denoted by brackets that don't have anything in them. If we wanted to add something to this list, we can say nums.append 7. And if we print nums here, then now our list contains 7. What append is going to do is it's always going to add it to the end of the list. So if we then say nums.append 11, then our list contains 7 and then 11. If we want to remove values from our list, we can say nums.pop. So what's happening here is we have our nums, we append 7, we append 11, and then we pop, which will remove the last value in our list. And lists are nice just because you can have like a linear sequence of data, and you can iterate through it, and you can just run. I mean, you see lists everywhere, right? Arrays of names, test scores. You can, if you have something like scores is equal to, say, like someone got a 50, someone got a 70, someone got a 100, another guy got a 99. Maybe someone like did terribly. We have this whole list of scores, and again, Python, of course, has amazing functions that you can use with these lists. You can say your average is equal to the sum of scores divided by the length of scores, and then we print the average. So the average is a 63.8. Right, so here's our list. You have the sort, method, which will sort your list. Oh, I don't know where all the other ones are. Yeah. Append adds an item to the end of the list. Extend will append all the items. So if you have two lists and you say you have one and you dot extend the other, then what that does is it appends all the items in that second list to the first list. So for example, if you had A is equal to 1, 2, and 3, B is equal to 4, 5, 6, you say A dot extend B, and then print A, you get 1, 2, 3, 4, 5, 6. This is obviously different if you appended B. What this will do is just actually tack on B to the end of A. So now you have a list inside of a list. Which brings me to my next point, which is that lists in Python do not have to be all of the same data type, right? You can have one mixed with true, mixed with hello there, and this works perfectly fine. You can say for item in A, print A, and type of A. Oops, or is it just type? Oh, sorry. Item and type item. Right? Just going through every item. You've got one, which is an integer. You've got true, which is a Boolean. Hello there, which is a string. You can mix and match however you like. Running low on time. I'm going to skip sets and go to dictionaries. Dictionaries are defined with curly braces, and what dictionaries allow you to do is have key-value pairs. And what that means is we can say my dog is equal to some dictionary. Say my dog like this. So here it's kind of like it's almost like a class if you've done object-oriented stuff. You have a dictionary, and you have keys, and the keys are associated with values, right? So if you have some dog, or you could have a list of these kind of dog dictionaries, and you could go through each dog and get their name, get their age, and again, of course, these dictionaries have all sorts of helper methods that you can use to do whatever you like with. You can, for example, do mydog.items. Items. You can iterate through this for key and value in mydog.items. Print the key and the value. So you got your key, you got your value. You can iterate through it. And what this is really nice for is it's essentially like an array, but the indices are just like strings. They don't have to be strings. They can be integers, even booleans. But instead of being limited in a list where you can only index it with numbers because it's sequential, in this you can index it with like whatever you like, and there's a mapping between the key and the value. And looking stuff up in a dictionary is really fast. It's constant time, so there's no need to worry about that. Really quick, let's build an initials counter. And what I mean by this is we will have something like this. Names is equal to John Doe. Let's do So we have this list of names: John Doe, Miguel Segura, Jacob Ellerbrock, Bruce Willis, and Clint Eastwood. And what we're going to do is we're going to count the number that, so if we have our first name and our last name, the initials are going to be just that first letter of each, right? And then we want to build a count of those letters. And the way we'll do this is we can say initials is equal to some dictionary, and we can iterate through the list and say for name and names. And again, Python being very helpful, we have a string method called split, which will split a name on the white space and return that as a new list. So we can do like first name and last name is equal to name.split. And if we print this out just to see what it looks like, okay, we've got that. If we wanted to get the first letter of each of these, we can index it with 0. So now I've got JD, MO, JE, BW, and CE. And then we can say if, or let's say first initial is equal to the first name at position 0. Last initial is equal to the last name at position 0. And what we can do is if the first initial is not in our initials dictionary, then this is going to be equal to 1, right? Because we just added in there originally. But if it is already in there and we've already been counting it, then we can say initials first initial plus equals 1, and we can do the same for our last name initial. And then after all this is finished, we can print initials and get this, right? So J has 2 from John and Jacob. D has 1 from Doe. Skipping ahead, E also has 2 from Ellerbrock and Eastwood. So this is one of the nice uses of dictionaries, is keeping track of the counts of different things. There's a better way to do this because this is kind of ugly, right? Having all this kind of checking. One thing that Python allows you to do is there's this thing called a default dictionary. And we can say that this is a default dictionary whose base type is an integer. And what that means is instead of all this checking, because in a regular dictionary, if your key is not already in the dictionary, if you try to add 1 to it, then that's going to throw you an error, right? It's like I can't add 1 to anything. There's nothing that exists in there. But if you declare a default dictionary with a default type, in this case integer, then if you try and do this, right, plus equals 1, it's going to go, okay, well, this isn't in my dictionary, but I know that the default type is integer, and the default value for that is 0. So I'm going to create that new key, and then create that default value, which is 0, and then add 1 to it. So then we can remove all of this kind of checking code. Remove this. And there you go, same thing. Except now it's printing out as a default dictionary. You can convert this to a regular dictionary, but you can use the default dictionary for all of your sorts of your dictionary purposes, right? J2, E2, all the others are 1, which is exactly what we're looking for. Okay. Functions. I'm sure you're familiar with functions. Functions allow you to reuse parts of your code. So if I wanted to say if I had some list of numbers 2, 4, and 6, and I wanted to, for each of these numbers, print out that number that many times. So print 2, 2, and then print 4, 4, 4, 4, and then 6, 6, 6, 6, 6, 6. One thing I could do is say for num and nums, right? So we iterate through all the numbers, and then for I in range num, print the num. This would work, right? 2, 2, 4, 4, 4, 4, 6, 6, 6, 6. By the way, you'll notice we don't use this I integer. We're just using it to iterate through this range. And so if you don't use the variable when you're just iterating, the common practice is to use an underscore like this. Right. But what we can do is separate out this logic into some new function called print in times, or print times, which will for underscore in range n print the n, and then we can separate this out and say for num and num, print times num. I'll move this to the top. And this will do the same thing. So I just ran that right now and it didn't change, so it worked. So functions allow you to modularize your code, and you don't have to rewrite and reuse stuff. But I'm sure you already knew that. But this is how you define a function in Python, is with that def define keyword, and then the name of the function, and then the parameters that it takes. So this can be one parameter, you can have two parameters, you can have all sorts of parameters. Another thing you can do is you can have default parameters. So if you say n is equal to 10, or let's do n is equal to 4, then what this is going to do is if you call print times without supplying your parameter, then it's just going to default to this 4, right? So then if we do this, this is going to go through. We have 3 numbers here, so this is going to be called 3 different times, but each time it's going to be 4. So this should be like 12 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? But we could instead say n is equal to num, and then this will work as we want. And then returning values. Returning values just means that the function doesn't have to just execute code. It can execute, compute something, and then return some data back to you to do with, to do something with. So if we have 2, 4, 6, 3, 5, 7, and our function was is odd, it took some number, and if n modulo 2 has if n divided by 2 has no remainder, then we return false, else return true, and then we can say for num in nums, print is odd. Right, so we call the isOdd function on the number, and we print out the result. So that's false, 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 because it's not odd. True, true, true. And I mean, we can condense this logic, of course, to something like this. This, oops. Which is the same sort of thing, right? So now we are just, instead of doing an if-else check, we can just return the value of the expression directly, right? So if the number has a value of a remainder of 1 when divided by 2, we know that's odd, so we can just return this expression, or the value of the evaluated expression. Okay. So, to put this all together, we're going to take a look at this final project, which is a text analyzer. I have this sample text here. Whoa. Okay. So what we're going to do is build out these functions. But not this one. Okay. Let's start with this one, most common word. So what we want to do is get all of these words and count them, and then return the most common word. So the way we can do that is we'll do sample or text. All right. So if we have our text, we can break it down into the individual words by calling .split. If you remember split, words is equal to text.split, and then we can print the words here just to see how that looks. Right. So these are our words: rowdy, the roadrunner. So it's built out into this list of words. One thing you'll notice is we do have some punctuation in the words, and that's just because the split will only work on white space, right? So it's not going to automatically format everything for you. And I'm going to keep it like that for now. I might change that later, but for the sake of time, we won't do that formatting. But we've got our words, and then to count the frequency of each word, we could have a dictionary like before, and we iterate through all the words and then update the value of that key by 1, like we did with the with the initials. However, Python is super handy once again, and from the same module where we got the default dictionary that allowed us to remove kind of the checking for if a key was already in the dictionary, it also has a counter object. And what the counter object does is take some iterable, like our list of words, and counts the frequencies automatically. So we can say frequency is equal to counter words, and if we print the frequency like this, then here we have a counter. You can see rowdy here is mentioned 4 times, the is 4 times, and is 3 times, and it looks like all the rest are 1 time. Counter happens to have a method called most common. So if we say, let's do our answer, the thing we want to return is frequency dot most common, and most common takes a parameter, which is the top however many most common, right? In this case, we only want the top one most common. If we print the answer here, then that's going to look like this, which is a list. And you might think the list is unnecessary because there's only one object in the list. But the reason we have a list is because if our parameter was like 2, then it would be a list of these 2 most common, right? So inside the list, we have what's called a tuple, which you can look into yourself, but it's kind of like a list. We've got this tuple of what the word is and what the frequency is. So our answer is going to be the most common top 1 in our frequency. And we want, if we index this object, this is going to be position 0 to get access to this tuple. And then position 0 of that to get the word. And then we print the answer, which is rowdy. But instead of printing the answer, we want to return the answer. So then whenever we call this function on some sentence or paragraph, it will return whatever the most common word is. If there's a tie, then I think it's just the first one that comes up. If you wanted to change that, then you'll have to do that yourself. But in this case, we don't care about ties. Okay, so that's one out of the way. Using some methods, using some interesting objects. Perfect. Okay, average word length. The average length of the words. This is going to be pretty similar, right? So words is equal to text.split. Oops. It's going to split across the white space again. We might want to like only do this once so that we can save some performance, but in this case it doesn't really matter. That would just be like a, if you're doing this a lot sort of thing. So we're going to split it, and then we want the average word length. Okay. Well, what we can do is, there are a few ways to do this. One thing that we could do is iterate through every word and have some counter variable that counts up the length of each word and then divide that by the number of words there are, which would look like this. Total length is equal to 0 for word in words. Total length plus equals the length of the word, and then we can return total length divided by the length of the words object. So if we do see, does that work? Yes. So the average word length here is 5.1 repeating. Which I think is perfectly, I'm just going to leave it at that for now. There are other ways you could do this with some more like functional programming style, but this is, we'll get into that a bit later. Okay, find palindromes. If you're not familiar with what a palindrome is, it's a word that is spelled the same forward and backwards, such as race car, right? R-A-C-E-C-A-R. It's the same if you have it forward. If you flip it, it's the same. And if we want to find the palindromes in our text, we can say again, words is equal to our text.split. And then for word in words, well, let's define a new function called isPalindrome word. And then the way we can determine if a word is a palindrome or not is we can return word is equal to, let's see, I don't want to do this. All right, this is going to lead into a tangent, but if you want to reverse a string in Python, what you can do is this, and this looks super weird, and I'll explain what's going on here. So what's happening here is in Python, strings and lists have something called slicing. So if you have a string that is, call me Ishmael, and you print S, then you get the full string. If you only wanted the first letter of the string, you would index it at location 0, right? Just like an array. If you wanted the second letter, index 1. If you wanted the last letter, well, you could get the length of the string and subtract 1, right? There's a handy little shortcut in Python, though. If your index is a negative number, then that's going to be automatic, right? So -1 is just going to be the last, -2 is going to be the second to last, so on and so forth. If you want a chunk, this is a slice operator, another colon, I know, Python loves colons, but you can specify a start and a stop, say from 0 to 5, and that's going to give you a string of the letters from 0 up until 5, exclusive, right? So 0, 1, 2, 3, 4, and you get calm. If you don't specify a start, then it's going to automatically be 0. So this is going to be the same sort of thing. If you don't specify a stop, then it's going to go until the end of the word. So 5 colon will start from position 5 and then go all the way down, Ishmael. And optionally, you can provide a step. So this is going to do the same sort of thing, but every other character. So we start at position 5, 0, 1, 2, 3, 4, 5. So starting at this E, going all the way down every 2. So E, and then skip the I, S, skip the H, M, skip the A, E. And so you have all of this logic with starting and stopping and stepping condensed into one syntax sort of thing that you can do, and it's really nice. It's really cool. One of the things you can do with this is provide no start, provide no step. So that's going to default to the beginning and the end. Sorry, no start and no stop. And your step is -1, meaning that we're going to iterate backwards. And this is why this is shorthand for reversing a string, right? So now we have it backwards. Call me Ishmael backwards because we're slicing the string, we're checking out the whole string, but our step is -1, so we go backwards. So if the word is equal to the word reversed, that's what a palindrome is. So is palindrome will take a word and then return true if it's equal to the reverse of itself. If it's not equal to the reverse of itself, then it will return false. So then what we can do is for find palindromes, we can say words is equal to text.split. For word and words, if is palindrome word, then we can append it to some pals array. And then after all this is finished, we return pals. Sample. And we have A and civic. So obviously any single letter word is going to be a palindrome. And we have civic. And we can get another one in here if instead of looking at just the words, we did this. So now instead of checking the word itself, we're checking word.lower. And word.lower, .lower is a string method that will take a word and convert everything to lowercase. And so now we should have Anna, which is a person in this story, but her name is capitalized, of course. .lower, did I mess up? Oh, is there comma. Right, that's what we get for not doing some formatting stuff. Oh, and it says the comma is a palindrome as well. So obviously there's some like formatting things you can do to make it better. Oh, and that changed our average word length too. But now we have our palindromes A, Anna, the single comma, and civic. All right. So if we wanted to analyze this text, what we can do is maybe have some dictionary, and in the dictionary we can say most common is like this. Which word length of text, and palindromes is find palindromes text, and we can print data is equal to this dictionary. We can print the data like so. Call analyze text on our sample text. That'll give us this, and if we wanted to format this, then we could do something like we can have a multi-line string like we saw before. We can say print most common word is, and then this is new, format strings, another detour. Format strings are really nice. So if you have like a number is equal to 4, and you wanted to say like my number is 4, typically in C or Java you do something like my number is, and then you do like plus, and then you convert that number to a string 4, and this will concatenate it. In Python you can do what's called a formatting string, or sorry, I mean it's typically shortened to F string. So you can do my number is, and then these braces you can put in, you can put an expression inside these braces, and it will inside the string be the result of that expression. So you can say my number is braces num. How about it? My number's 4. How about it? And so then here we can do, make this an F string. Most common word is, and then data most common. Average length is, go to our data dictionary, get the average length, and if we want, we can round this. Actually, I'll do this in here. We can round this to give us maybe only the first 3 decimal points, right? So that's just a parameter in the round function. And say palindromes are data palindromes. There you go, right? Most common word is rowdy. Average length is 5.041 rounded, and then palindromes are our list of palindromes. Pretty cool, pretty cool. Okay, I'll pause there for questions if anyone has any. All right. Lastly, we're going to get into some nifty Python tricks. If this will. Oh no. Yes. Okay. Nifty Python tricks. Okay. So we have this code snippet here with a numbers array. And if we want to create a list of all these numbers squares, then what you would typically do is you would iterate through the numbers, say for number and numbers, or for num and nums, then squares dot append num times num, right? This is pretty typical. In Python, there is an excellent tool called a list comprehension that allows you to do something like this, right? So you have your nums. Nums is equal to 1, 2, 3, 4, 5, 6, 7. And squares is equal to this new list, which is denoted by the the brackets. And what this new list is comprised of is x times x for x in nums. And so the way this works is you've got your regular iterator. So for x and nums, that's what you're doing. And then you're doing some operation on each of those values. In this case, multiplying it by itself, with itself. And you'll just build out a new array, a new list with that operation that you've done to it. And we can use this for some of this stuff. So for example, instead of saying total length is equal to 0, we could say lengths is equal to the length of the word for words, for word in words. And then we can return sum of lengths divided by the length of the words array. And this will give us the same result. Right? That's pretty nifty. We can do the same sort of thing for a lot of examples. Similarly, if we have two arrays, students and grades, right? Students just containing the names of the students, Jonathan, Bob, Jose, Emily, and Rose. And we have the grades, 100, 12, 89, 96, 72. If we wanted to kind of build up and match the students with their grades, we could do just a simple loop for I in range, the length of the students. The student is going to be equal to the students array at location I. The grade is the grades array at index I as well. And then we can print out student and then the grade with our f string that we just learned. And this works. However, in Python, you can do this, which is you say for student comma grade in zip students grades, and then print like that. Which, if I show you how that works, say S is equal to A, B, C, B is equal to 1, 2, 3, C is equal to you and me. Then if we print out zip A and B, which we'll need to convert to a list, if we zip A and B, then it's just like a zipper, right? Because your zipper will, interlock the little teeth, and it does the same sort of thing here. It will just iterate through and like grab each, the same indices for each iterable or list. So in this case, if we're zipping A and B, then we get the first location at both, which is A and 1, and then the second location, B and 2, and then the third, C and 3. And we can actually zip however many we like. So in this case, we're zipping 3 objects, and so that returns us a list of all of the first elements, and then all of the second elements, and then all of the third elements. Which, if you think about like matrices, 2D arrays, tables, this is one of the ways to do like a shorthand of just getting all the columns. If you zip all the rows together and then iterate through that, then that's the columns. So that's pretty neat. One more trick. If we have a names array, Abraham, Zach, George, Bert, if we sort this names array, we're sorting strings, which the default sort is just alphabetical order, right? So that would sort Abraham, and then Bert, and then George, and then Zach. If we wanted to sort based on some other factor, like the length of the name, then doing this in C or C especially is not intuitively obvious, right? Python makes it intuitive by letting you supply a key function that will apply this function to every element in the list, then sort that list based on the value that each item, what that function returned for each item, and then when it sorts, it's sorted based on that value. So in this case, our key is the length function, which for this Abraham will return 7. This will return 3. This will return, 6? And this will return 4. So then it'll sort the names array based on those values. And then we have 3, 4, 6, and 7. And we've sorted that successfully based on length. Super easily, right? You just say names.sort. And what's our key? Well, our key is the length function. You can create your own functions to sort on if you want some very custom sort that isn't built in. In this case, this is the count of A's. Lambda here is just a way to like declare a one-time use function and never really use it again. So we can say that our key is equal to this new function, which takes in a name and returns the count of A in that name. And so that'll sort first. This one has no A's. Bert also has no A's. Zach has 1 A. And Abraham has 3 A's. And so that's all in sorted order as well. If you didn't want to use a lambda, because maybe you're not comfortable with it just yet, you could have your own, just write the function like this. Count A's. That looks like count as. And you do return name.count A. And then if you have your names, Abraham, George, Bert, and what was the other one? Zach. Then you could say names.sort, and your key is the function count num A, and we print names. And that sorts it just like we want. All right. That, unless, or I'll open the floor to questions. If anyone has any question like, how do you do this in Python? Is this possible in Python? Obviously, I didn't go over like object-oriented stuff. If anyone has any questions, I will do my best to answer them. Otherwise, maybe you have some questions for me later. This is my contact information if you need it. But I'm open to questions if anyone has any. Thank you for coming. If you didn't get to check in, this is the QR code once again. Recommend it. Helps us out, and it helps you out too. Other than that, thank you for coming.